Hey kids, here we go. New week, new stuff. So this week we're going to be modeling linear relationships. This is kind of an extension of what we did a couple weeks ago. So this first part I'm going to kind of breeze through a little bit. We're going to be modeling using point slope form and slope intercept form. Again, we know how to write these. We know how to write equations of lines in point slope form. We know how to write them in slope intercept form. So now we're just going to take some situations and use these forms to model our functions. Okay, so let's take a look. Let's see what we got. So what we have is a candle on a menorah burns at a steady rate. After 30 minutes, the candle is 11 inches tall. And after 15 minutes, the candle is 10.5 inches tall. We're going to use point slope form to model the function, then determine how tall the candle will be after 2.5 hours, so 2.5 hours. So here what we have is we have 2 points. Okay, so we're going to start by recognizing that we have 2 points. And time is going to be our x. Okay, so we define our variables. X is going to be time, and y is going to be height. And that's how many inches tall it is. Okay, so we have 2 points, and we're going to write these 2 points as an ordered pair. We know that after 30 minutes, the candle is 11 inches tall. Okay. And I guess I should say after 15 more minutes, so after 15 minutes more, then the candle is 10.5 inches tall. So that tells us that after 45 minutes, the candle is 10.5 inches tall. Okay. And here we're going to say after burning for 2.5 hours. Okay, so we'll just, this 2.5 hours is going to be 2.5 hours total. So we've defined our variables. We now have 2 points. We're going to use these 2 points to get our slope, because remember, this is point slope form. We have points, now we need to get the slope. Okay, so please remember that the slope is the change in y over the change in x. The change in y, going from 11 to 10.5, we get 10.5 minus 11, that would be negative 0.5. And the change in x, 45 minus 30, is 15. So since I'm not a huge fan of having decimals inside fractions, we're going to go ahead and multiply the numerator and denominator by 2, because that's going to give us a whole number in the numerator. So that's going to give us negative 1 over 30. So our slope is negative 1 over 30. Okay. Now I'm going to use a point. I'm going to pick a point. So I'm going to go ahead and pick this point and call this our x1, y1. And remember, this is all review. We know how to write the equation. We know how to write the function in point slope form once we have this information. Because remember, it's y minus y1 equals m times quantity x minus x1. We know our slope is negative 1 over 30, and our y1 is 11. So we got y minus 11 equals negative 1 over 30 times quantity x minus 30, because 30 is our x1. So our 30 is our x1, 11 is our y1, negative 1/30 is our slope. Now at this point I want to know, so this is how we use point slope form to model the function. So we're good there. Now we're going to determine how tall the candle will be after burning for 2.5 hours. Okay, 2.5 hours. Up to this point, we've been using minutes. So 2.5 hours is going to be 150 minutes. Okay, it's important to maintain the label and the scale on which you're counting. Okay, so, and this is, since it's time, it's going to be an x value. Okay, so this is going to plug in for our x. So 150 minutes will be x. Let's do it. So we've got y minus 11 equals negative 1/30 times, we've got 150 and then minus 30. Now we just do the arithmetic. Y minus 11 equals negative 1/30 times 120. When I do the subtraction, negative 1/30 times 120 is going to give us negative 4. And then when we add 11 to both sides, we get 7. Okay, so that means the candle will be 7 inches tall. So again, we use point slope form to model it, figure out what our either our x or our y will be, substitute that in, do the arithmetic. Okay, let's do one more like this. Now here we're going to talk about a swimming pool. Okay, a rectangular swimming pool has a volume capacity of 2,560 cubic feet. Okay, water is being added to the pool at a rate of 20 cubic feet per minute. Okay, rate, as soon as you see rate, this is our slope. So rate, that's our m. Okay, determine how long it will take to fill the pool completely if there are already about 1,200 gallons of water in the pool. Huh. Well, the capacity is in cubic feet, but this is in gallons. So we need to have some kind of relationship. So use the fact that, oh, hey, here it is. Use the fact that 1 cubic foot of space holds about 7.5 gallons of water. Okay, so since this is in cubic feet, and since our slope is in cubic feet, let's change these gallons to cubic feet. Okay, so we're going to change the gallons to cubic feet. Okay, let's do that first. So 1,200 gallons, 1,200 gallons, put that over 1. Well, not equals. So 1,200 gallons, and I want to multiply that by, let's see, I want cubic feet, so 1 cubic foot, the feet cubed, cubic foot, is about 7.5 gallons. Okay, and this is back to the unit analysis that we did a long time ago, dimensional analysis. Okay, so here, because gallons is in the numerator, we have to put gallons in the denominator. Because labels can cancel, numbers cannot, but labels cancel. So here, this now equals 1,200 times 1 cubic foot. So this is 1,200 cubic feet over 7.5. Now we just have to take 1,200 and divide by 7.5. So we take 1,200 divided by 7.5, and we get 160. So this 1,200 gallons that are already in there take up 160 cubic feet of space. So now we know that, so again, let's define our variables. So our variables here, remember, the slope is change in y over the change in x. So that means that x must be time, because that's per minute, change in x. And then cubic feet must be our y. Okay, so now it says, let's see, there are already 1,200 gallons of water. So that means at 0 time, there's 1,200 gallons or 160 cubic feet of water in the pool. So this is our point. This is our slope. Let's go ahead and write the equation. So again, we got y minus y1 equals m times x minus x1. We know that that's our slope. This is our x1, y1. So we've got y minus 160 equals 20 times x minus 0 times x minus 0. All right, now I'm going to do two things at the same time. X minus 0 is x, and 20 times x is 20x. So this is y equals 160 equals 20x. Okay, and we want to know, let's see, where's the question? Determine about how long it will take to fill the pool completely. Well, completely is 2,560, and that is cubic feet. So that's our y. So we're going to take 2560, and we are going to substitute it in for y. We're going to substitute it in for y. So here we're going to take 2560 minus 160 equals 20x. Okay, we did that substitution because of how much we can fit in there. That's going to be completely full. So let's go ahead and do the arithmetic. 2560 minus 160 is going to be 2400 equals 20x. Divide both sides by 20. We get x equals 120. Okay, so 120, so x equals 120. Remember, x is time, and time is measured in minutes. So it will take 120 minutes. You can say 2 hours. That's fine. So to fill the pool, it'll take 120 minutes. So when we're dealing with point-slope form, we get a point, we have our slope, we move on. And we write our equation and then figure out what we need, what the question is asking, and go from there. Now, something that's a little bit easier, something that we've done before, is slope-intercept form. Okay, so we're going to do this one quick just to make sure that we're all on the same page when it comes to slope-intercept form. So a taxi service takes $3.50. It's a ride fee plus 75 cents per mile. I need to ride to the airport from my house, which is about 25 miles away. We're going to model the function using slope-intercept form, which is y equals mx plus b. And then can I use my $20 Visa gift card to pay for the taxi ride? Okay, so here we go. Let's see. So a $3.50 ride fee, that's before we do anything. So that's at 0 time. So that's our B. 75 cents per mile, that's a rate. That's M. And then money, so Y is money because the rate is money per mile. So X is miles. All right. So let's go ahead and put in B and M. So we've got Y equals 0.75x plus 350. So that's modeling the function. And then the $20 Visa gift card, that's money. So we're going to put that in, we're going to substitute that in for Y. So the question is, does 20, so we got 0.75x plus 350, and we're going to see whether our x, our miles, is more or less than 25. Okay, you could also substitute in 25 and see if you get more or less than 20. That's up to you. You can go either way. Here we're going to subtract 350, so we get 1650 equals 0.75 times x. We divide both sides by 0.75. And we get 22. We get 22, so x equals 22. So $20 will get me 22 miles. but I need to go 25. So can I use my $20 Visa gift card to pay for it? No. $20 is not enough. Okay. All right. So in the next video, we're going to talk about how to do this in standard form, and then you're going to have a bunch of practice. Okay. So this was point slope form and slope intercept form. All right. See you in the next video.